So I appreciate coming out to be part of the seminar. So today I wanted to present this work it's sort of part of the larger project I'm working on. I'm basically interested in evaluating, statistical evaluation of different types of algorithmic recommendations or algorithmic decision making. So actually, I think some of the stuff that I'm talking about is, I'm not an economist, but you guys probably have thought about, or maybe some of you are interested in. So I wanted to acknowledge my collaborators. It's sort of the part of the larger project that I'll give a talk today. Okay, so just to motivate, I don't think I need to convince you that the AI or data-driven algorithms are everywhere in today's world. If you flip the phone, you'll be interacting with any kind of these algorithms. But I think humans still make many consequential or inconsequential decisions. So for example, myself, I haven't yet reached the point where I just say, hey, Alexa, just do a grocery shopping for me. I still push the button to decide which, they might recommend something to me, but then the final decision of purchase is done by me. Okay. And in particular, what I'm interested in, more consequential decisions, although some of the stuff I'm going to talk about is obviously applicable to many other contexts. So we haven't yet outsource these type of high-stakes decisions to AI or algorithms, right? Even though the doctors may be just blindly following what's being suggested on the screen. At least we know that this is true even when the human decisions, humans are notoriously bad decision makers, but we still have a human beings making the final decisions, okay? And maybe that's because we want to hold somebody accountable instead of something or some algorithm accountable. And that might change, obviously, in the future. So what I'm going to talk today is AI-assisted or algorithm-assisted human decision-making. Okay? And the idea here is that humans make decisions with the help of AI or algorithm recommendations. And this includes all the routine decisions made by individual daily lives, but I'm going to focus on a specific consequential decision made by a judge in the context of criminal justice system. Okay. So just the broader questions I'm being interested in the last few years is, how do AI recommendations influence human decisions? Do they actually help us make better decisions, more accurate decisions, or fair decisions? Okay. A lot of computer scientists in particular have studied accuracy and fairness of the algorithm itself. That's actually, it's a lot easier to study. It's mathematical objects. For us, social scientists, we study as humans. We're a lot more complex and a lot more heterogeneous. So relatively few research has been done on their impacts on human decision, how they interact. Like, how does the algorithm interact with the human complexity? And in particular, very little is known about AI's bias, how that interacts with human bias. So that's sort of something that I'm being interested in. So today I'm going to present you the statistical evaluation framework for this type of recommendation systems. And if you're doing an experiment, or if you're someone who is going to run an experiment, I'm going to say this framework is going to propose to randomize human alone decision group versus the human plus some AI recommendation group. So you randomize. Depending on the case, either human makes a decision on their own, or human makes a decision with the help of AI. Okay? You can also do observational studies if you're willing to assume that assignment of which arm you're going to be at is unconfounded. And then I'll show you the methodology. Once you have these experimental observational studies, how to analyze it. Okay? In particular, I'm interested in comparing how good humans do on their own, how good they do with human plus AI recommendation, and then what would happen if you just get rid of the human and then let the AI decide everything whatever they think is good. Okay? So that's sort of the comparison in a statistical way. is what I'm interested in. And I'm also interested in like optimally combining human decisions with AI recommendation. In particular, when should we provide the recommendation to humans, or when should human follow the AI recommendation in order to improve the accuracy of the decision. Okay. And if I just talk about this, then there'll be a boring econometrics talk. So I'll have this first ever field experiment that actually we run to evaluate the pretrial public safety assessment. So this is the algorithmic recommendation that were given in the US to judge based on for their pretrial decision. Okay.
Can I ask a very basic question?
Yeah.
What is AI?
Oh gosh.
I'm thinking about the post office scandal in the US, where decisions were taken basically by the computer, saying this postmaster is embezzling money.
Yeah.
But
so
there's not a fancy algorithm. It's just a computer.
Yeah.
So when is AI?
Yeah. So I don't have any dog in the stake for that fight, but so you can think of AI. You can replace the AI. Whenever I say AI, you think of it as algorithmic recommendation. So there's some input, and then there's some output. Okay. Because some people say that's not AI. That's just like stupid algorithm. So I'm going to show you the algorithm that's much more simpler, or at least the final algorithm that you see would be very simpler, even though the model that produced that could be complex. But I'll show you ChatGPT as well, just so that people are happier.
So you're basically saying it's non-human decision making.
Yeah, so it's like a deterministic, actually it could be a stochastic, but deterministic algorithm that there's some inputs, and then it will basically tell human, this is what you should decide. And the human may or may not follow that recommendation. You can ignore it, override it, and so on. Yeah, so, there's debate among us whether we should get rid of AI, buzzword, but we'll stick with it for today. Okay, any other questions? Okay, if not, I'm going to go into the actual talk. So first, let me tell you about this application, because I think it'll put in a good context. So it turns out all these algorithmic recommendations have been used in the US criminal justice system for quite a long time, if you broadly define the algorithm or AI. Okay. So the particular one that I'm going to focus is something called the pretrial public safety assessment, PSA. And it's a decision that judge makes at the first appearance hearing, which basically means that, say you get arrested on the street, and then you'll be brought in front of the judge. And then judge is going to make a decision. Okay? Judge basically makes two decisions. First, whether judge decides whether to release somebody, pending disposition of criminal charges. So these are people who are arrested, but they haven't been officially charged yet. Okay, so you could be completely innocent, for example. And then if you release, under what conditions? So the particular thing I'm going to focus today is cash bail. So in the US, there's a bail that judge may impose. What that means is that you have to pay, you have to post a bail in order to be released if judge decides to do so. But there could be other conditions, like monitoring condition, like judge may say you have to wear the ankle bracelet, for example. Okay. So why they do that? Well, they want to avoid the predispositional incarceration, because these people are not yet, even charged or being determined guilty. And so, but at the same time, they want to preserve public safety. So they don't want to release someone who they deem dangerous to the public while they're waiting for the trial. Okay. So judges are, by law, required to consider 3 risk factors along with other factors. First thing I'm going to call FDA, which is the arrestee may fail to appear in court. So if they get released, they may not come back when they are supposed to show up. Okay. Arrestee may engage in new criminal activity, NCA, or arrestee may engage in new violent criminal activity, NPCA, while being released. Okay, so the judges are concerned about these 3 negative outcomes as a way to sort of preserve the public safety. Okay. Judge may have some additional information we don't actually observe. So human decision is much more complex. So for example, judge may have police affidavit, like police describes the circumstance of arrest, which we don't unfortunately observe. And judge may talk to the defendant, or defendant may have a lawyer, and the judge may talk to. Now, I don't want to get you too excited because all this data set, the data set I'm going to analyze are petty crimes. Okay, so there's no murder, for example. So they're like stealing something and things of that sort, type. Okay. And so a lot of defendants don't even have like lawyers at that point in the first appearance hearing. Okay, so PSA as a AI recommendation to judges. It classifies arrestees according to these 3 different risks. It's derived from an application of machine learning algorithm. Could be a logistic regression. Okay. To some training data set. It's a training data set. It's a nationwide sort of arrest record training data set based on the previous observations. Okay. And then a lot of people ask, like, does the algorithm gets updated every second? No. It's like a simple, algorithm. I can show you more later if you have time. But it's used in more than 25 states. Okay, so it's quite prevalent system that's being used across the United States. In 4 states, places like Arizona or New Jersey, it's used statewide. So every county uses this system. This particular PSA is particular algorithmic recommendation system. There are many others, like Compass, for example, you may have heard of. Okay, so the field experiment that I'm going to analyze today is done in Dane County, Wisconsin. Have you been there? If you've been to University of Wisconsin, Madison, Wisconsin, that's Dane County. Okay, so if you've been to University of Wisconsin, Madison, you've been to Dane County. Okay, so there, PSA is a weighted indices of 10 factors. Okay. Importantly, age is the only demographic factor. The race or gender is not used. Although judge knows because they see the arrestee in the court. Okay. 9 factors drawn from criminal history is also being used. Prior convictions and FDA. Okay. So what is this PSA thing? There are 2 separate ordinal 6-point risk score for FDA and NCA, sort of indicating the risk levels for each of these negative outcomes. And then there is a binary risk score for new violent criminal activity. Okay, so whether this person is likely to commit a violent crime, well, if they are released. And then these 3 scores are taken together and produces aggregate recommendation. So signature bond here just means that you can sign a piece of signature and then be released. So you can think of this as a release decision without really much condition. And then cash bail, whether it's a small or large magnitude. Just this distinction is about like $1,000. That's sort of the small, less than $1,000 is a small cash bail, and then the more than that is large cash bail.
Why not using gender or race as a
well,
predictor? I mean, gender is a very important predictor of criminal activity.
Yeah.
Just statistically.
Yeah, so I think it's just a concern that, these factors should not be used to,
Should not, but I mean,
yeah, but of course it's, statistically correlated, and you see that. So that's basically the reason.
Like the decision is because it's discriminatory.
Yeah, and that's actually the whole reason that they wanted us to evaluate this PSA, the jurisdiction, was they're worried, they're concerned about racial discrimination and so on. Yeah.
There's no bail doesn't exist.
Oh, so the signature bond is basically no bail. So you can sign a piece of paper and then you be released without paying any.
I thought, but can you stay, like no bail would be like you stay.
Oh, I see. Oh, unconditional detention? Yeah, there's no such a thing. Because the crime that I'm analyzing is very petty crime.
And a large cash, does it give you an amount or it's
Like the recommendation just says large cache, but it's understood as sort of above 1,000 in this context. Okay, any other questions? All right, so judge may have, as I said, have other information about REST-D. So they might know that, for example, the REST-D has a family, like kids, in which case they may not want to detain the REST-D or give a cache bail so that they cannot go, right? Because they have to take care of kids. Or if you're employed, judge may be inclined to let that person go. But we don't observe that. Yeah.
Sorry, man.
Yeah.
So it looks like that's what bankers do every day.
Oh, yeah.
So is there any relationship with the scoring methods and the banks?
No. So the method I'm going to talk about is very general. So it could be used for like loan decision or some other context, or even shopping decision. But this is sort of the context that I'm going to talk about today. I don't know. I prefer to just talk about in the context of application than just like go straight into the notation. Yeah.
Do the judge know about the algorithm and how?
Yeah, that's a good question. Yeah, so the judge actually knows he's in the experiment. Yeah. There's a single judge. Okay, so don't Google.
He knows that he's in the experiment and he knows about how the algorithm works.
Yeah, unfortunately, we couldn't basically fool him. Like, IRB won't let you. I had to get consent from the judge. Yeah, so there might be some Hawthorne effect. The fact that he knows he's being studied might influence his decision. Okay, so field experiment. Basically, what's nice about this is this algorithmic score can be calculated for every case. That's just a formula. Okay? And what we are able to randomize is the provision of PSA. So as I said before, for some cases, the judge sees the algorithmic recommendations, and in other cases, they don't. Okay? And then some people always ask, like, oh, why don't you randomize the algorithm itself? It's like, good luck. That's not an ethically easy thing to do. Okay. So the results I'm going to show you is sort of based on the Interium data. Okay, but we made this data set public available. So if
one more question. The data on which the PSA has been trained is for when? For a year? For 2016? Or for the period
earlier.
2000?
Yeah, it's an earlier year. I don't have a precise time period, but it's
very recent.
Yeah, it's relatively recent, earlier year, but not at the same time. Yeah. Okay, so here is the piece of paper judge gets basically, and so you can see there's 3 scores here. One is the new violent criminal activity, that's binary, and then 6 point scores for failure to appear and new criminal activity. Okay, and these are the risk factors that are used to calculate these numbers. And there's a formula that's behind it. So you can think of it as, and the judge sees this, so what that means is that and actually in the control group, judge has access to this information as well. And so what's new is really just how these are weighted to get these 3 different factors. And then at the bottom, you see the recommendation, overall recommendation. In this case, it's a signature bond, which means that you can sign and then be released. Okay. Yeah.
Just to make sure there's like 3
Yeah.
outcomes, right? Signature bond, small bail, large bail.
Yeah. But here I'm going to focus on just the binary decision of whether to give a cash bail or not. I'm not going to analyze the amount. Okay. Yeah. For the remainder of the analysis. Okay. Any questions? All right, so basically we are able to randomize this across different cases. Just to quickly data, to just give you a sense. So you can see, so on the left you have no PSA, so that's a control group, and on the right you have a PSA. And you can see that about most of them is signature bound. About 2/3 are basically release decision, and then 1/3 parentheses percent of total. And so the mostly like that judge is releasing. The arrestees, you can see that female, relatively fewer female, number of female, about 20%, and mostly male. And then the white and non-white ratio is about even, which if you've been to Dane County, that's 90% white population. So non-white male is overrepresented. You can also see that about 30% of people don't show up, fail to appear. And about 30% of people commit a new crime. And about 6% of people commit the new violent crime. Okay, so there is a sort of actual risk of people committing a negative outcome. And the total data set is about, this slightly less than 2,000. Okay, any questions? Good. So the first question I wanted to ask is, does the judge agree with PSA? Like how often do they override? And so this is a case where I'm comparing the human, the judge decision with when the judge doesn't see the recommendation against the PSA score, okay, PSA recommendation. And you can see that there's more agreement on the diagonal. So about 70% of the time, the judge agree with the PSA, okay? But there's fair amount of disagreement. In fact, that the judge tends to be a little bit more lenient. So judge gives the signature bond decision, which is basically this, when the PSA says this person should get a cash bail, okay? And then the fewer case, judge goes the other direction. Okay, now, so this is when the judge actually sees the PSA, okay? And I'm comparing, this is a treatment group against the PSA score. Yeah, so the increase is the slightly increase, like 3 percentage point. Like a slightly increase is the agreement. So judge sort of is, pulled a little bit towards the PSA. But still there's, substantial number of cases, about 25%, there's disagreement. And again, the judge tends to be a bit more lenient than the PSA itself. Okay. And this difference, even though it's sort of subtle, it's actually statistically significant impact on the judge's decision. Okay, so the question is, okay, so judge seems to be ignoring sometimes, and other times it's following. And when judge sees the score, they seems to be a little bit influenced. Are they being influenced in the right direction? Are they, ignoring the right cases? That's basically the question I want to ask. Yeah.
The cases could differ as well. We don't see it from these numbers, but the cases in the 4 categories may not be the same in the human space and human.
Right. So the treatment group is the human judge sees the recommendation. In the control group, judge doesn't see the recommendation, right? That's basically the data structure. Okay. We don't know what would happen if we just let the PSA decide what the decision should be. Is that what you're asking? No, sorry.
The kind of cases in each of the 4
could
categories differ.
Oh yeah, totally. Yeah. So this, the cases here could be completely different from the cases here, right? And you'd hope, right? Like, if it's actually someone is committing a crime, hopefully judges give him, less lenient decision. So yeah.
So if we look at the table, it seems that having access to the PSA influences the judge's decision such that they will follow a little the recommendation or something like this. So direct question is, does access improve the quality of the decisions or not? And do you have access to recidivism or
so for
cases?
Yeah, for this, we have outcome for the actual, right, FDA, NCA, and DCA. So what happened afterwards? But of course, these are affected by the decision itself. Yeah. So it's not, it's endogenous, but you know, we'll have to deal with that. Okay.
Sorry, I'm
Yeah.
not sure so how can it be influenced if you have no people that get in jail? So basically,
Well, they might get in jail. Like if they can't pay the bail, right? They'll be detained. They'll be detained until they can post the bail.
Excuse me, if I-
Yes.
did you collect also information on how much time it takes them to make this decision?
Yeah. How much time for the judge?
Yeah, so is that
yeah.
an issue at all?
Very good question. Unfortunately, I don't have that information just because these are very quick decisions. So like, I don't know. I would say like each day there's like, 20 decisions to be made or something like that. So they're not like hours of deliberation. It'll be like and that's part of the reason they use PSA is supposed to make the decision more efficient. Yeah.
sorry, maybe it's too much questions.
No.
But feel free not to answer.
Yeah.
Looking at the data, I was just wondering whether you could have access to the time the decision is made, and maybe the algorithm might have more impact at different times. I'm thinking about this study on Israeli judges before lunch and after.
Yeah, no, I think that's right. Like we didn't collect that information, but it's a very low resource court, so we couldn't ask too much. But okay, all right. Yeah, so basically in this experiment, there's sort of two key features. One is that obviously randomization, or in observational studies, you'll be strongly ignorable, unconfounded. So this is a comparison between human alone and human plus AI. But we have also something I call single-blinded treatment. Okay, so single-blinded means that AI recommendations, or PSA in this case, affect the outcome only through human decision. Right? So human decision is potentially affected by the recommendation and some other covariates that humans observe, and also some unobserved confounder might be affecting human outcome. But this one is exogenous, and it has no direct arrow to the outcome, only affecting. So you can think of this as instrument, like exclusion restriction, since for the economist. Right.
So the outcome is whether or not bail is paid, not the behavior of.
Yeah, this is whether or not. Well, it could be a bail post, but in the analysis I'm going to do is whether you committed NCA or NVCA or FDA. That's what I'm calling outcome. But anything that happens after the decision, it could be used as an outcome. But for the analysis I'm going to conduct, I'm going to look at what the actual behavior, arrestee's behavior after the decision as the outcome. So whether you actually showed up in the court or didn't, failed to appear, or you committed a new crime and got arrested, yeah.
Why do you want to instrument to take care of the confounders?
No, I'm just saying this is by this. You'll see this why. But yeah, so here the key is the arrestee doesn't know whether they're in the treatment group or control group. Okay. We didn't tell arrestees they're in the experiment.
Is that to be able to causally identify the effect of AI only?
Yeah, I'll show you. Yeah. Not quite, but well bounded. Okay. All right. So let's go to the methods. So the notation, I'm going to use ZI, the algorithmic provision of algorithm, human decision, DI. Observed outcome is Y. Okay. So it's all binary. In the potential outcomes framework, we have decision as a potentially function of the provision, and then the outcome potentially function of the provision and decision. But because of the single blindedness, I only need to write the outcome as a function of the decision, not also as a function of the provision. Provision only affects the outcome through the decision. Okay, so that's the instrument part. And then we assume there's a randomization going. So potentially conditional on the covariates, the algorithmic provision assignment is independent of the potential outcomes and potential decision. Yes?
So the Z is not seen by anyone else than the judge. For instance, the bound officer does does not get the AI.
Right, unless judge tells them.
And, okay.
Sometimes,
Okay.
very few times, there is evidence that judge said, I have algorithm. But most of the time, judge didn't. Well, we think. Like looking at the transcript, it seems, we didn't quite tell a judge, like, don't tell him.
There's also the bond officer, right? So he's a guy who that doesn't know about that Z, right? That information, that AI. And that would be, again...
Well, the judges, in this court, judge is the one who actually determines the amount of the bond.
the social workers that takes care of how the bond is paid.
Oh, I see. We didn't show them the algorithm. So we think, we think exclusion restriction here is reasonable, but there's always a potential violation. Okay, all right. And then if you observational studies, you have this overlap. Okay, so what's nice about this, I think, at least in principle, these assumptions can be guaranteed by the experimental design. And no other assumptions are required for the method that I'm going to talk next. Okay, so these are the only assumptions that I'm going to make. All right, so how do we evaluate these algorithms in human? I'm going to use simple classification metric. Okay, so it's 2 by 2, outcome on the left, on the rows, and decision on the columns. And let's consider just generic decision. So this could be a decision by human alone, a decision by AI, or a decision by human plus AI, or anything. Okay. So here I'm going to call positive decision, not normatively, but just a positive decision to be cash bail. Okay. Negative decision to be signature bond. So on positive means cash bail, and negative means signature bond. Okay. And for the outcome, I'm going to focus on y of 0. So y of 0 is the behavior of RST if they are released. Okay. Under the counterfactual scenario of the judge decides to release that person, how they behave. So this is an important outcome because PSA is supposed to predict that. PSA is supposed to predict what would happen if you release this person. Okay? And I'm going to call, if someone commits, say, NCA, for each outcome you can define this. But for someone commits new criminal activity, then I'm going to call this positive outcome. Again, not normatively, okay, just the name. And then negative if no NCA. Okay? So once we define this, we can think about false positives, true negatives, false negatives, and true positives. Okay? So what is false positive? False positive is the case where you made a negative decision. So this, false positive is right up here. So you made the positive decision. That is, you made a decision to give a cash bail. But the outcome was negative. That is, the person wouldn't have committed a crime. So you didn't really need cash bail. You could have just let that person go. Okay? That's basically the false positive. And false negative is the opposite. So you release that someone, but then that person committed the new criminal activity. Right? And then you can think about the true negative, true positive as well. Right? And we're going to focus on y of 0 for that reason. Okay? So once I make this sort of classification scheme, then I can assign the loss, just like every analysis, decision analysis would do, to each classification outcome. I'm going to assign the loss of 1 to the false negative just to normalize everything. And then we can define something I'm going to call classification risk. Okay? So that's basically the proportion of false negatives times the loss associated with it, plus proportion of false positives times the loss that's associated with it. So that's basically you can think of an expected loss of any decision-making system averaged across all cases. Right? And my goal is to estimate this from the data for each different decision-making system, and then say which decision-making system is better. Is human better without AI versus with AI?
Sorry, and you're estimating the L10 and L.
These are, yeah, so these are assigned by the decision maker, right? So these are like how much you care about the false negative versus how much you care about false positive, because, right, depending on who you are, you might assign different loss. And you might ask, like, okay, like, how do you pick that number? Well, that's a good question. So not by the econometrician, for sure, okay? But in the analysis, I'm going to ask, like, how big this has to be in order for you to prefer one system over another. So you can ask those questions.
Why do you need to sum up? Why can't you just compare the system?
Oh, you can compare each one. No, you can, yeah, you can compare each one separately as well. Yeah, which we'll do too. But if you want sort of a single number that decides, you know, which decision system you want to adopt, because the court wanted us to know, like, you know, tell them, like, which system is better. Like, should we just get rid of PSA or not? Then you need the decision that will, right? So then, like, you have to tell them, okay, give me a loss for each outcome, and then I'll give you what you should do. Yeah.
Just a
Yeah.
clarification about the setting. So we observe the outcome irrespective of the decision, right?
Oh, right. Yeah, we observe.
Not in a world where, say, the decision is detain you versus not detain you, and so if I detain you, obviously you're going to show up in court.
Right, exactly. Yeah, but the detention, like right, so that there's no detention decision for this kind of cases. It's already cash bail. Yeah, but if you ended up being held in jail, then you show up. Yes. Wow. Unless, what's that?
But there could be some influence. I mean, it's not like, you know, it's not like.
Yeah, that's true. You can get.
I mean, you know, obviously, if you are asked to pay money, then you may be less likely to commit a crime because you will be more.
That's right.
So I mean, there is a causal aspect, and in the other direction
yeah.
as well. If you are, you know, released without any bail,
Yeah.
you are more likely to. So I mean, the outcome and the decision are not independent as they would be, you know, in an ideal.
Yeah.
You know,
So the cash bail is a very controversial. I don't know if France has one or not, but in the U.S. it's very controversial because some people think the cash bail actually, you know, doesn't really prevent the crime, because now you have to come up with some money, and you post the bail, but then you go out and then you're short of money, so you may, you know, maybe more likely to commit, like steal something again. So there's a controversy about. So I don't want to make any sort of monotonicity assumption like in the usual IV case where the decision only affects the outcome in one direction or anything like that. Yeah.
There is a study showing that radiologists are averse to type 2 statistical mistakes. So
Oh.
they will overprescribe.
No, yeah.
They don't let people with the disease go.
Mm-hmm.
In the case of pneumonia.
Yeah.
In that case, I was wondering whether you could show if judges are also more averse to type 2 statistical errors, letting go people that are innocent, and whether AI might decrease.
Yeah, I'll show you. Yeah. So this is exactly right. So you can think of, like, you can apply this to like a decision maker being a doctor, the AI recommendation being some AI generated, you know, diagnosis, and then the outcome could be the actual disease onset. Okay. So you could use this in the other context, I mean, just a different notion of what's false positive and what's false negative. Yeah.
And just along those lines, because I was wondering,
Yeah.
of course, how crowded prisons are going is
Oh,
going
yeah,
to be important
yeah.
for the decision.
Yeah.
So that would be captured by your weights L100 and so
Yeah,
on.
that's true. Yeah, so judge could assign that based on, you know, you can't basically put everybody in the jail in the U.S. So just overcrowded. Yeah, so a lot of those decisions might be incorporated into that. Now, I'm not really doing the quota. Like, I'm not constraining the budget things later when I do optimal decision. But yeah, there's a lot of interesting questions here.
And could you take that into account over time to see if judges
Yeah, that's a very good question.
are
So
changing?
yeah, so we have a separate paper that shows like judge actually tends to follow more if the arrestee gets rearrested when the judge released that person. Yeah, but this for this analysis, I'm only looking at the first time encounter So there's no rearrest. Okay, so how do we compare? I'm going to go a little quickly. So if you're a econometrician and you're disappointed, you can ask me over lunch or dinner. So the difference, I'm going to basically look at the difference between the risk, right? The classification risk I defined between the AI and human. Human plus PSA, and then the human alone decision. Yeah. And it turns out there's basically a selective labels problem that is like we don't observe y of 0 when the judge actually gave a cash bail. Right? We don't know what the arrestee would have done if the judge released that person without any cash bail, when indeed judge actually gave a cash bail decision. So it turns out the false negative proportion is identified, right? Because when the judge actually released that person, we know the proportion of people who commit a new crime. But the false positive proportion is not identifiable because these are the people judge gave a cash bail decision, and we want to know what is the proportion of those people who would commit a new crime if they weren't receiving the cash bail decision. Okay? So the blue thing is basically that, false positives, difference of the false positives between two systems is not. So each of these terms, one is under human AI, the other one is under human, is not identifiable. Okay? But it turns out the difference between these two unidentifiable numbers is identifiable. We are playing with algebra, and like turns out, and that's sort of the aha moments. I go, oh, okay. So by randomization, we can replace Z1 and Z0, right? It's independent of Y of 0. And then by law of total probability, that we can decompose each one to be two probabilities. One is identified, one is not identified, but rearranging will give basically difference will give you difference will basically give you the identifiable quantity. Yeah. All right, and then we do some W robust estimation, but I'm gonna skip that. Okay, we can talk about this if you're interested. We can also do like when do you prefer human alone versus human AI? So from a statistical point of view, we can do this by a hypothesis test. So you have a hypothesis that human has a lower risk than the human plus AI. And then you have an alternative hypothesis that human has a higher risk than human plus AI. Okay? And we can do a hypothesis test. And in fact, we can invert this test because this is a function of the loss. It depends on the loss, right? How much you prefer false positive versus false negative. So we can do inversion of the test to obtain a confidence interval on this, right? So the range of the loss that would make you prefer human alone system over human plus AI, and vice versa. Okay? And then there is a range that where it's ambiguous. Statistically, it's ambiguous. Okay? So rejecting the null means you prefer human AI over human alone, and rejecting the alternative would be the other way around. And the failure to reject either means that you're statistically ambiguous. Okay. All right. The next, I wanted to compare AI alone with human decision. Okay. So what happens if we get rid of human judge and then completely outsource decisions to AI? Okay. The trick is that we don't have an experimental arm that has PSA alone. Okay. So unfortunately, both of these false negative proportion and false positive proportion are not identifiable. Okay. However, we can derive the short bounds on these differences. And I'm going to sort of skip the details, but actually these bounds are very informative, as I show you. Okay. The bound width depends on the agreement between human and AI. So if there is a sufficient agreement, we know what would happen if we let the AI decide for those cases. And when the human disagree with the AI, that's when we don't know what might happen. So that's where the unidentification comes from. But if there is a sufficient agreement, from the data, you can actually learn what would happen if you let the AI decide. Okay? So that's basically the bounds. And I want to emphasize that this is applicable to any generic AI. So it doesn't have to be the AI that used in experiment. It could be any decision system you want to try out. So that's why I did the ChatGPT at the end. Like, what happens if we get rid of a human and then like, let the ChatGPT decide? Okay, so that's sort of the advantage of this framework is that you can do this for any algorithm. And then we do double robust estimation. Okay, let me skip that. And then we can also do hypothesis test. Like we can do, when do we prefer getting rid of human and just stick with AI? Okay. It's a partial identification. It's a little bit complex. So the null hypothesis is about the lower bounds and upper bounds, below 0, above 0, and so on. But otherwise, it's the same trick. So yeah, when human is preferred over AI, and when AI is preferred over human, and then there's ambiguous case. Okay. Just two more things before we show you the results. You can also ask the question of like, when should we provide AI recommendation? Right? When judge should see the recommendation. So basically, you can do like optimal policy learning. A lot of economists now do this. Okay. So here, basically, pi of x is the your new decision rule, which tells you when you should provide the AI or not. So if it's 1, you provide human makes a decision with the algorithmic recommendation. If it's 0, then the d of 0, so the human will make a decision without the algorithmic recommendation. And then you try to find the pi that minimizes the classification risk. So that's the optimal. So human in the loop, and you're trying to decide whether to provide the algorithm or not in order to minimize the classification risk. Okay. And you can also ask, when should we follow the recommendation? Okay. So here it's partially identified, so you have to look at the upper bound. But basically the idea is that when we know the AI alone system is better than a human decision maker, that's when we should follow the AI. Okay? And it's a function of x. So what kind of cases should we follow the AI recommendation? And you can think of this as a worst case optimization. So because the difference between human and AI alone is partially identified, you only follow AI when when we know for sure that the AI is better than human. If it's ambiguous, the human is a default. So I call this like a safe policy learning. So if you're not sure, you just go with the human as a default.
Sorry, maybe I missed this, but in the X,
yeah.
you have the same information as the algorithm,
yep.
or you have extra information?
No, you could have extra information, but here you only have information as the actual algorithm that's being used.
Why? I mean, didn't you just raise and say, for
yeah.
white people or for men, the algorithm does very well, but for women it doesn't?
Yeah, so we could use, I guess we didn't use it, but yeah, we could use it. Yeah, for sure. Oh, we may have actually used. No, I guess we decided not to use it. Okay, all right. All right, so let me show you the results. And so I'm going to show you a series of these graphs. So let me explain. Okay. So for there are 3 figures. So this is for each outcome. So this is for the failure to appear. And on the left, you have misclassification rate, which is the sum of the false negative and false positive. So this is when you weight the false negative and false positive equally. Okay, so these added together is on the left. And in this case, I'm looking at the impact of PSA. And if it's positive, PSA is actually harmful in that it's increasing the number of mistakes. And if it's negative, PSA is actually reducing the errors. Okay? And then on the x-axis, you see the overall and then different groups, non-white, white, female, male. So first results shows that basically the PSA recommendations don't really improve human decision in terms of classification risks. And you can see that all these cases, false positive proportion, false negative proportion, misclassification rate, like a confidence interval is overlapping, maybe helping a little bit for the females in terms of false positives, but otherwise it seems pretty null results. Again, null results, new criminal activity, and then new violent criminal activity. Okay, so the PSA is not, it's influencing the judge, but it's not really improving judge's decision in any way. Okay, so now let's look at the PSA alone decision. Okay, turns out this is when we can show that the if you get rid of the human judge and then let the PSA decide, then actually the decision is less accurate. So here, this is a partially identified case. So you have like a thicker bar that presents the point estimate of bounds, and then a confidence interval, 95% confidence interval. Okay, and I want you to see on the false positive. So you can see that the false positive is much greater if you let the PSA decide and get rid of the human. That means that, as I showed earlier, like remember that the PSA tends to be more harsh. So the false positive is the case where like PSA says give this person cash bail, but you could have released without committing crime. And across the board, and especially non-white, you can see that the false positive proportion has increased about 8 to 16 percentage point.
Can you see that's because the algorithm was discriminatory?
Well, this shows that algorithm is particularly harsh for the non-white population. Yeah. So, but also male. Generally male and non-white male in particular. Same thing for NCA. Basically same results. Here even the misclassification rate, it's interesting because it's increasing the false positive proportion without decreasing the false negatives, right? Even though those are trade-off in general. And then you can see here misclassification rate is increasing for non-white population. And the NVCA also. Okay. All right. And so you can ask like human alone system, when do we prefer human alone system over PSA alone system? Okay. So here I'm showing you for each different subcategory, when do we prefer human alone versus when it's ambiguous. Actually, we don't have any case where we prefer PSA alone. Okay. And on the y-axis, you see the ratio of the loss. So above the dotted line is you care more about false positives. And below the horizontal line, you care more about false negative in terms of ratio of the loss. And you can see if you care about false positives at least like twice more than false negatives, you should probably, and if you're non-white in particular, you should probably have a human judge instead of PSA.
Do you have access to the algorithm? Could you run
Yeah.
the algorithm on the data?
Yeah.
Because here, if I understand correctly, you're telling us that you never prefer the algorithm alone.
Yeah.
But maybe this is because, Nicolas's question, it doesn't include all the relevant information.
Right, right.
So could you reproduce
Oh, I see.
what the algorithm would have done if it had known
You're
more?
putting in the race and
Yeah.
gender.
Yeah.
basically.
So we could. Yeah. Unfortunately, we don't have access to the national data training data that they used. So we can't. We cannot build it our own algorithm in that way. Yeah, but we are in negotiation with some county to let us, since the current one sucks, let us build better one in Las Vegas. where there are a lot of
I guess.
a lot of petty crimes are. Large statistical power. It's many observations. Okay, so same thing for NCA. Basically, you prefer human when you care about false positives. Okay, so when do we optimally combine? Last thing I want to show you is the PSA recommendation with human decision. So this chart shows that basically the only time we should provide the PSA recommendation is when the NVCA flag, the binary flag, is 1, and then these other scores are high. Okay, so these numbers are number of observations. So relatively small number of observations. This is only time PSA can be useful for human judge. Right? So when it's like a recommendation is a very extreme. And same thing, when should we follow PSA recommendation? When the flag is 1, and then the FDA score and NCA score is relatively high. That's when following the PSA recommendation will reduce the classification risk relative to the human alone. Okay? So PSA is used for only cases with the extreme recommendations. All right, finally, some people say PSA is an AI. What about real AI? So I asked, actually, this is a Llama 3, not ChatGPT. It's open source LLM. So I told them, you're a judge in Dane County, Madison, Wisconsin. I asked to decide whether or not arrestees should be released on their own recognizance or be required to post a cash bail. If you think the risk of unnecessary incarceration is too high, then arrestees should receive own recognizance release. On the other hand, if you should assign cash bail if the following risks are too high. And then we include the 3 different risks. And we basically provide characteristics of these, the description of inputs, PSA inputs. And then for each arrestee, we say, this arrestee has the following characteristic. Should this arrestee be released on their own recognizance or given cash bail? Please provide your answer in binary form, 0, 1, and followed by a detailed explanation of your decision. My Harvard Law School colleague says the description provided, explanation is going to pass his class. It's in Harvard Law School. So it's like, okay. Like, seriously. So I asked him, so what are you teaching in law school? And he's like, oh, I don't know. Okay. So here's what we get if we read that and then compare with human decision and whether Llama 3 is better than human. And you can see that there's a massive false positive proportion under this particular AI and this particular prompt relative to the human decision. And actually, even the false negative proportion is, it's a little bit better, but not really increasing. So it's a lot more increase in, so turns out the Llama 3 is very strict, a lot less lenient, except the female is sort of balances out. So there is sort of the gender balance there. But for all these other groups, mostly male, misclassification rate is increased. Yeah. Now I should say, as you know, LLM is very sensitive to the prompt. So I told them, you're being too harsh, and then next round, it released everybody. So it's he's okay. LLM is, says okay, I understood your concern. And then next time I asked, it was release everybody. So yeah.
Can you rank the performance of judges and identify a group of judges for might have this AI?
Yeah, so those are good questions. Unfortunately, I only have single judge for this case. We have several other jurisdictions we've been working, so we have multiple judges there. But yeah, maybe in the observational study, you can combine with observational studies to do some of that. Because it's, obviously a different judge is very different. And they may react to the same algorithm different way. Yeah. Okay, so the same results for NCA, same results for NVCA. Basically, like the real AI is not too promising either. Okay, so just let me conclude. So basically, we propose a methodological framework for evaluating 3 decision-making systems, because these AI recommendations are in the society quite a bit. So we think that it's important to evaluate this before you put them in, use them in practice. So these 3 different systems you can use to evaluate, and I think it's reasonably widely applicable. We have to make sure that there's single-blinded treatment assignment, and you know, in the observational studies, you need unconfoundedness and overlap. But it doesn't require AI-alone treatment conditions. So even when the decision is pretty high stake, you can use this kind of evaluation framework. And it's like minimal assumptions. I think that's one of the advantages of the approach. Okay. If you use R, we have a package called AI Human. Yeah. And basically, we conducted this RCT and found that the PSA recommendations don't really improve human decisions. It's only extreme PSA recommendations are useful, and both PSA and AI decisions perform worse than the human decision in this particular case. So that's all I have. So thank you.